It's a real pleasure to speak to you today about the transformative powers of large language models. And it's wonderful that Peter Ward already gave us an introduction as to how to actually use them in the sense of how we can apply them and what it takes in terms of skills to make use of those. Large language models and generative AI are topics that have taken the world by storm ever since ChatGPT was made public in November 2022 and DALI 2 in April of that same year. And I think it's probably fair to say that 2022 was the year that AI has reached mainstream public attention for the very, very first time. Since then, not a day seems to go by when we're not hearing or reading about new, more powerful tools, how they're being put to use in ever more areas of our lives, or what risks emanate from that technology. So the race is on. Who will be leading that new frontier of technology development? And the associated investment figures currently being pumped into this domain are outright remarkable. In this keynote here, I'd like to share with you my view of why and how this emerging technology is impacting virtually all aspects of our global societies and our economies and our lives at the end. Central to this transformation, as Peter Ward just already showed us, are large language models, such as GPT and BART, tools that are really pushing the boundaries of what we once thought was possible and that are leading us towards a future that not too long ago seemed really like science fiction. But before we delve in, let's define some of the key terms you'll be hearing a few more times the next half hour. And that's just to make sure that we're all on the same page when we are using these terms. So let's begin with what a large language model is. It is, at the end, a type of a machine learning model that is trained to perform a wide range of natural language processing tasks. It's a deep learning algorithm. That means it's typically based on a deep artificial neural network that's trained to recognize, summarize, generate, and predict text and other forms of language-based data. Large language models are trained, as the name implies, on massive amounts of text data in order to learn the underlying patterns and structures of language. For example, OpenAI's GPT-3 was supposedly trained on a corpus of 45 terabytes of data. Because of all this, language-oriented applications such as conversations, knowledge management, coding, and writing are where large language models excel and deliver the greatest value. But then what's generative AI? What's the difference actually? Actually, there really isn't a difference because large language models are a subcategory of generative AI. And what generative here means is that the machine learning model no longer just takes existing data and performs calculations on it, such as classifications, predictions, etc. But the models are now able to create new data, new content. That is unique. That's really new. As mentioned before, the large language models are trained to perform tasks of natural language processing. Other generative AI tools, and again, Peter Ward mentioned these, such as DALI or Midjourney, are large image processing models. Increasingly, and I think very interestingly, what we're seeing more and more is a move towards what the so-called multimodal generative AI models. That means they have a unique ability to generate new data, new content across different modalities, such as images, videos, text, audio. And the developments, again, are fast. While GPT-3 was only a large language model, its successor, GPT-4, can now also process images and generate text based upon those images. These large new models have really brought novelty to AI. which by itself has been around for a long time. However, until recently, machine learning was largely limited to analytical AI. That's predictive models used to discover and classify patterns in data and content. There's this one classical, often quoted machine learning problem I'm pretty sure you've all come across before, and that is to train an algorithm to identify cats and images. Now, with generative AI, we no longer are limited to perceiving and classifying an image or text for that matter to see, well, is this a cat or not? But now machine learning is able to create an image or a description of a cat on demand. And all it takes is a natural language prompt engineer. And that is a really, really big change. Hence, the final term that I don't want to miss here for the purpose of this keynote is transformational. Transformational refers to the ability to induce a market change in nature or form. It implies that we're dealing with a significant shift or alteration, something that fundamentally changes the way we do and perceive things. Generative AI, large language models are, if you look at the press, if you listen to podcasts, are widely considered to be transformational because they have the potential to revolutionize entire industries, automate many tasks that we previously thought were no candidates for automation. And they can really change the nature of work itself in a very profound manner. Now, devil's advocates could argue, yeah, well, there've been instances before where technological advancements were hyped up and widely anticipated to bring about significant change, but ultimately fell short of those expectations. Blockchain is one such example where there was a lot of enthusiasm around its potential to disrupt finance, supply chains, and other industries, but in reality, adoption has been much slower than expected, and for several reasons. Similarly, AI itself has gone through several hype cycles already, with high expectations around its promise, but if we're honest, mixed results in terms of implementation and impact. But some things are different this time with the LLMs and the generative AI. First of all, it's the general nature of the technology. Generative AI is a general purpose technology, like few others we've seen. The more computing power, the more data, and the more users I put into it, the better it performs. And it's sometimes still, at least in unexpected ways. Large language models can learn from unstructured data without requiring a lot of human supervision, if at all, for these tasks. Pre-trained models can be fine-tuned with relatively small amounts of training data to perform new tasks. Demonetization was mentioned by Peter Ward before, and that's again also important because the barrier to adoption of the technology are so low at this point in time that almost any one of the estimated 5 billion people currently on this planet who have internet access can, thanks to a natural language interface, operate a sophisticated chatbot that's based on a large language model at no cost with little or no training. We all can get better by doing our homework on prompt engineering, but we can learn quickly and we don't need anyone to teach us. Last but not least, why is this different? That's the unprecedented speed of adoption. When ChatGPT was launched, it had 1 million users within a week of its launch and 100 million users 2 months later on. All of those feeding it new data and making the model better day by day. So that leaves the question, how do we make best use of the transformational powers that now we seem to have at our fingertips? First of all, and that's really not specific to large language models at all, but to all business-related decisions is there should be a value, typically a business value that we seek to achieve. Once we have that, um, we can move on. Now, the second thing is at the present stage of technology cycle, or the development cycle of generative AI and large language models, I should say, a good use case should fulfill three criteria. First of all, and that's by pure nature of their core purpose, they should be dealing with a lot of text and seek to use natural language as a way of communication. Secondly, a human actor should be in the loop, because this approach combines the best of human intelligence and machine intelligence and can help address the concerns around controllability, bias, and unintended consequences that we're still seeing. Lastly, the application should not be mission critical as long as LLMs continue to occasionally hallucinate and some model behaviors are not yet fully understood. Sundar Pichai recently said in a podcast that he would use an LLM anytime to get some creative input on the name for a new family dog, but he would be very careful, if not to say he wouldn't use it, if it was about getting a diagnosis or a treatment for his family, for any of his family members. So that can tell you that while these large models are already extremely good at what they do, they are still flawed to a certain extent and need careful management, careful handling, I should rather say. Anyhow, even under those limitations here, the possibilities for using large language models abound already today. So let's look at a few examples from a selection of sectors. Chatbots, they are a natural field of application for large language models. Probably all of us have in the past interacted with bots and quite often were left somewhat underwhelmed by the experience because the bot was very limited in the scope of answer it was able to provide. Its language understanding was limited too, and its output was rather artificial. With the advent of ChatGPT and the likes, a whole new quality of chatbot experience has arrived where conversations are human-like. Add to that the capabilities in language understanding and their ability to provide fast, accurate responses, seemingly accurate responses at times, and you have a winner for a variety of use cases and customer support. If you have been among the millions of unfortunate people who held an airline ticket at the outbreak of the coronavirus pandemic and got stuck in an airline call center's hotline while trying to get a refund on your ticket, think of what a truly capable chatbot could have done for you and those poor customer service agents in that call center. Now, moving on to HR. In the much-touted war for talent, speed in progressing candidates through the selection and hiring process is key. At the same time, it remains as important as ever to make sure that there is a good skill and culture fit between company and candidate. Especially in larger organizations which handle huge amounts of applicants, this is often a big challenge for the HR teams. And here, large language models can help in multiple ways. It starts with drafting job descriptions and job postings. It supports interested candidates in evaluating whether this employer and job vacancy actually matches good with their profile and their interest, while simultaneously it helps recruiters to make a similar assessment from the perspective of the hiring company. All of which, of course, does not mean that there will be no more interpersonal human-to-human conversation in the hiring process. It rather means that these conversations will take place primarily with the most promising candidates before they get hired by someone else, or they lose interest because they just haven't heard back from you for so long because you were just busy working through the data. Another case, patent analysis. Companies, and that's no news, companies that are able to innovate are much more likely to survive and thrive in the long term than others. But what you think is an innovation might already exist, or at least has been ideated by someone else in the past. Now you could ask, why should I care? Well, because you're unlikely to be able to obtain any worthwhile intellectual property rights for that idea if it's not novel. An idea that is not novel cannot legally belong to you. In consequence, then, this usually means that the idea will have little or even no commercial value. And if someone owns the right to it, you even risk having legal action taken against you. Therefore, at a certain stage in the innovation process, you should ascertain that the novelty of the idea is there and that it can be exploited legally. How to do that? Well, patents are a common form of documenting inventions and ideas, and hundreds, literally hundreds of millions of such documents reside in databases of patent offices worldwide. In this context, large language models can help search for what is called prior art. So, has it been invented, thought of before? It can canvas large amounts of existing documents, categorize, summarize in order to support your decision whether there's merit in further pursuing that idea or rather not. And if all lights are green and you actually bring this innovation to see the light of day, you need to sell it. And again, this is where large language models can help. Because marketing is fundamentally built on words and images to capture prospective buyers' interest and make them think that all that separates them from eternal bliss is your product, your service. So, content creation, content personalization, and content optimization are perfect use cases for large language models because they're heavy on text and language, center on human interaction, and if the sale is not successful, there is no immediate harm done. An exciting prospect, especially here now, comes from the emerging multimodal models because they can actually generate content, as I mentioned before, in various forms, text, images, artwork, that then are aligned for this one very specific marketing purpose. So that is a very interesting aspect. One thing that's close to my heart and which I think is one of the most wonderful opportunities for LLMs is education.